Okay, so this we're going to talk about light, and I've drawn a diagram here showing the primary colors, secondary colors, and the tertiary colors. The primary colors are the outermost, the outermost color in the circles here, red, blue, and green. Remember that this is light. Okay, maybe I should thicken that a little bit. So when it comes to light, it's not the same as pigments. Pigments is what you studied, as a student when you're growing up, color pencils and all that. The more colors you combine in color pencils, the darker they will become. But when it comes to light addition, right, it's not the same. In fact, the more lights you combine together, then the brighter, and eventually it will turn white. You can just actually imagine this in Wheel of Fortune. Wheel of Fortune is a game that was really popular. It's a game show popular in the 90s. So you have all these contestants, they will be spinning wheels of different color, and eventually the wheel will look like it's completely white when it's fully turning. So anyway, the combination of red and green forms the secondary color yellow. This is cyan and this is magenta. This is the best color I can come up with. And um, the addition of color could be quite complicated. So let's talk about light subtraction first. Okay, when it comes to light subtraction, we use something called filter. Filter is something that allows only a color of certain uh, uh, light of certain color to pass through. Okay, white light contains all of the 7 colors. Okay, Roy, Great Britain, the fourth. So all of these colors combine together to form white light, and the light that is in your room right now, the light from sunlight and all that, that's considered white light as well. So this filter, for example, if let's say this is a red filter, then when the white light passes through, only red will pass through it. And if you have a screen here, you will see red light only. So a filter here is not something that is very sophisticated. Even your plastic bag works a bit like a filter. So if you put like a green plastic bag around a light bulb which gives out white light, eventually you only see green light passing through. So if it's a red filter, then you will see that lah. But what if it's a secondary color? What if it's a cyan filter? If it's a cyan filter, then you will see blue and green together as well as a cyan there. So there you go. That's what it is. So let's imagine the situation here. Let's say you are in a very dark room, because some of you have really, like, you have a big difficulty trying to comprehend what's going on in class. But let's say I have an object here and it is blue in color. So I'm gonna put the color blue here. Okay, so this object is blue in color normally when there is white light, but sometimes you don't have white light. Sometimes you're in a dark room, and then you have a torchlight. All right, you have a torchlight like this, and then you put a filter, and let's say this filter is a red filter. I hope this one works fine. Okay, so this is a red filter. So the light passing through beyond this filter will only be red. Okay, red light passing through here. What color will this object look like? Let's say this ball, this sphere here, is blue in white light. Now it's total darkness except for this red light here. Now it touches this object here. What happens? Okay, so this object appears blue because it reflects blue color. Sorry that the color is still in red. Okay, it reflects blue color. So if you look at an object and it is green in color, it's because that object takes in white light, reflects green, it absorbs blue and red. It's absorbed and it doesn't like green. So a leaf, okay, looks green because it doesn't absorb green color. The white light from the sun is given sunlight, which is white light, and then dia terima semua warna kecuali hijau. Alright, so it reflects green. I don't know why I suddenly talked in Malay there. So that's why an object appears green. This object appears blue because when you give it white light, he will always absorb red as well as green, the two primary colors. He always reflects blue. Therefore, if this object here is blue in color normally, and you give red light to it, he will absorb the red light. It will reflect Nothing, because there is no color to reflect. There is no blue color in red light, obviously. There is blue color and red color in white light, which you already eliminated through the filter. So now you have only red light, blue light is gone. There is no blue light to reflect, so it will look completely black or dark. That's why some cars look completely black, like blue cars and all that. They look completely black when you use the street lamps. Some of the street lamps are orange in color or red in color, so they will look black lah. Okay, so that's just an easy example lah. You need to do as much exercise as you can. That's the easy part. Now we're gonna make an example, the harder one. This is gonna be a secondary color. Let's say this is yellow. All right, you know that an object appears yellow because it reflects red and green. All right, it reflects red and green. So what happens when you shine, let's say, blue light towards it? Same lah. Just like this, you have a filter. There's only blue light here. There's no white light. If it's white light, he will reflect red and green, and he will absorb blue. Now you only give blue light, so he will absorb it lah. So when he absorbs blue light, he doesn't reflect anything. It will look completely black. Let's replace this with magenta. Magenta is a combination of red plus blue. So red and blue is shown towards this object. Here, what happens? Blue is absorbed. Red is reflected. Therefore, this yellow object here, due to having only magenta color being shown to it, will look red. It will look red in the based on what you see. So I hope that is okay when it comes to colors. Alright, just try to study as much as you can. I accidentally did that. Okay, so now we're gonna study refraction, because I don't think I covered enough of this in class. I hope this is enough, because we're trying to finish the syllabus as fast as we can. And here we go. I've already drawn what we call, let's say this is glass. This is glass, and this is air. So now, light is passing through the air and entering the glass. The question here is how will the light be refracted? Because you know that refraction happens whenever they pass through from an area of different densities to another. So the density of air, I hope you know what density means, otherwise you just have to read it. The density of air is obviously lower compared to glass, because in glass the particles are closer together and here is very far apart. In a sense, you can say that light can pass through more easily through air, and when it enters the glass, it will change direction a little bit. Okay, how do you know how the direction that it will change? You need to draw what we call a normal. This shaggy line here is called a normal. It's always drawn with holes in the middle because it doesn't actually exist. It's just an imaginary thing, but you need this in order to draw the resulting ray. So this is a straight line, and the refracted ray here will depend on what is the density of the area it's going to. If it's going from the lower density to higher density, like air to glass or air into water, he will be refracted closer to the normal. So you can see here, this is a big angle and this angle is smaller. So this is what happens low to high density. It will start moving straight. Sorry. Okay, let's say this is a straight line. Now it looks somewhat straight. What is the direction it goes after? You have to draw the normal also, because you want to get the an accurate result. So let's say this is the normal. The normal is always 90 degrees to the surface. So if let's say the surface is like this is the normal. If the surface is like that, then that is the normal. It's always 90 degrees. Basically, you are drawing a cross on that surface lah. So now, when it goes from area of this is low density and this is high density, it will go further from the normal. So as you can see here, the angle between the normal and the refracted ray is bigger compared to this one. So if this is A and this is B, A is bigger than B. So this is how refraction happens lah. Okay, so I hope that's it for now. I think this is the most important part that is hard to understand. Scattering of light and dispersion of light, the prism and all that. Just remember that red lights and violet, even though they are part of white light, in a sense, they move at different wavelengths. Of course, in your syllabus, they say they move at different speed. That's not actually accurate, but I think that's accepted for your level. So I'll see you guys maybe next chapter. I think this is fine.